the lab tonight, while I'm talking about the discussion, you can go ahead and submit your name in the lab because it's going to be a video we're going to be watching on data, how it flows on a network right after discussion. This week, you're due, this Sunday, the topic for your research is due. Remember, if you have not put thought into it over Labor Day weekend, which I don't expect you to, you can click on that Pick Research Topper, refresh yourself with the topics. If you don't like any of them or not interested in them, after you looked them up, you can think of one your own. If it has anything to do with networking, you're fine by that. 3 review questions, week 3 review questions, and chapter quiz. We'll also be catching up on grades this weekend for this class on my 130, so you'll be getting an email over the weekend on your grades that have been caught up. Hour of code. We had last night, and also a couple things coming up. The end of the month, Learn Coding with Robots, and next month, the Tech Expo, RBC Tech Expo. And if you haven't registered for either one of those, you can go to rbchourcode.com to register, watch videos. We had 17 register last night for the downtown location, which was pretty good for the first one. If you've not been to the downtown location, I recommend the one we have next is in October, and we'll be doing Minecraft. You'll create a complete app in an hour, a mobile app in an hour of Minecraft. So if you're a Minecraft guru already, you'll like it. If not, you'll like it anyway because it's a fun game to learn, fun coding language to learn, drag and drop, and it'll be full. It's almost already sold out, so Minecraft one always is. I think Minecraft's been #1 on the App Store for 7 years, 6, 7 years, something like that. So anyway, any Minecraft gurus in here? Anybody? Or prior Minecraft people? All right, cool. So now we're going to talk about a whole bunch of different things as far as introduction to networking. We're going to look at organizations involved in networking, some protocol and OSI information, and then we'll watch a video on how packets move from a network. When you click on a link, how does it get from a web server in, say, China or Japan, that page that you clicked on, to your browser? We'll also look at the types of network address in OSI. So standard organizations, the word standard is basically documents that everybody agrees upon. In networking and even in hardware for networking, there's standardizations that companies have agreed upon for like Wi-Fi, right? Or wired, or satellite, that if you want to create a hardware to work on networks in the US, you have to abide by certain guidelines, right? Now, if you don't want to abide by those guidelines, there are countries you can go to and not abide by those guidelines. But in the US, there's guidelines you have to go by, and so there's standardizations for that. Standards are important because it helps us to ensure compatibility. Really, that's what it's all about. So when a company creates a new, let's say, Wi-Fi router, everybody that has, majority of people in America can connect to it with their devices, whether they have an iPhone, iPad, Droid, whatever, laptop, desktop. It also defines minimal acceptable requirements. So like minimal hardware requirements. So like say if you look at the box or the CD, DVD package for like say Windows 10, there's minimal requirements for Windows 10. Also minimal requirements for Windows Server. Are they optimal requirements? No, but they're minimal requirements. And so that's one thing you'll need to note as well. And we'll talk more about that this semester. Some of the organizations involved in networking, ANSI, IEEE. IEEE just met here a couple weeks, or last week, I think. They meet here like every other month. And they usually have a presentation and dinner. Students can become a part of the student chapter for IEEE, which I recommend. It's not real expensive. It used to be free, but it's still not real expensive, and you get a lot of benefits, and a couple conferences for free you can go to, all the events here locally you can go to, and they usually have good discussions and good demos that companies will come and bring a demo on whatever new technology is out. But ANSI standards apply to the type of NIC cards people or companies create. Like an example would be like the Linksys, or not Linksys, Intel would be a popular one. That's probably the most popular NIC card out still today. But there's other ones out there like Buffalo that you might have heard of that creates NIC cards, wired and wireless both. IEEE, these guys are involved in communication protocols. And then network professional responsibility is just to be familiar with all these groups. You don't have to know in-depth knowledge of them, but be familiar. And you might even decide down the road to be a part of one of them. You might be a type of person that really enjoys putting together standards, or you like putting together functionality for things to work well. You might enjoy getting a part of one of these standard boards, because that's all they do is they rally government officials to get standards passed. They write standards, and that's all they do. ANSI is an American Standard Institute, American National Standards Institute, 1,000 plus representatives from industry and government. It determines standards for electronics industry and other fields. It's voluntary in compliance and standards, and it has rigorous testing. Most hardware devices will have an ANSI sticker on it, which is meaning they voluntarily applied their documentation and requirements to their equipment, the ANSI documentation requirement equipment. And again, it's kind of like accreditation for colleges, or accreditation for doctors or lawyers. There's a whole bunch of different accreditation boards out there, and this is just like an accreditation type of entity, if that makes sense. When I was going through college, I worked for a guy who was he accredited private schools. There's a company that accredited private schools. It would take about, 2 years to get accredited. They had to go through like 25 meetings, fill out all this paperwork, a lot of red tape. But they had to make sure all the teachers had their certification, all their buildings were up to specs, all their curriculum was up to specs, all of their reports from inspections from bathrooms to classrooms to parking lots to sports, all passed. It wasn't just like, everybody could teach. That wasn't enough. It was pretty unique in the requirements. And do what?
What do they gain from getting this accreditation?
They gain basically, in some cases, can get grants they can't get otherwise, money. And then other cases, when parents see the accreditation and read up on it, and they may choose that school because it's accredited and the other one's not, and the one isn't, if that makes sense. So they have to meet a set of standard, basically, is all it is. But there's a lot of them out there. But ANSI is one that's really big. It's huge. It's pretty much every vendor I know of has the ANSI sticker on their product to meet standards of ANSI. EIA and TIA, Electronic Industry Standard. It's a trade organization, U.S. firms only. Sets standards for the U.S. Standard firms, companies, and members. Helps write ANSI standards, lobbies the government, both in Washington and also state government as well, for favorable legislation. Like it'll lobby the FCC to require, an example here recently, commercial for anybody to fly a drone. That was a big thing. FCC did not want just anybody flying a drone, so they compromised with legislation that now if you have a drone over X amount of weight, you have to register with the FCC so they know where you live, they know your name, they can do a background check on you if they want to, and you are part of a FBI registry after that because you have an FCC, basically an FCC license, quasi-license by signing up your drone. If you have a drone, you already know that because when you buy one, they tell you to do that. But that is a standard or lobbying example that the FCC wanted no one except for professionals, especially when they started getting the high-end drones out that could go long distances and, possibly could infringe on people's rights if a person was flying it that didn't act responsibly. And so, but there are standards even with the drones that you have to apply, like you can't fly around large groups of people. You're not supposed to anyway. Can't fly over 400 feet in the air. Do people do both? Probably, yes, definitely. But people who are law-abiding citizens usually, adhere to those type of rules. Next, the TIA, the Telecommunication Industry Association. It's a subgroup formed in the U.S. for Telecommunications Suppliers Association. Focus of TIA is standards for information technology like wireless, satellite, fiber, telephone equipment. The TIA EIA, you'll actually be playing with this in the next couple of weeks with Cabling Lab. The 568B series is a guideline for installing and setting up cabling. So if you look behind you on the wall in the back of the room, you'll see red and white cables. Here in a couple of weeks, you'll be creating both. You'll be creating the red type of cable, even though yours is going to be white. It'll be a crossover cable, the red are. And then the straight cable is the white cable. But on the cable itself, if we were to go pick one of those up and look at it, you would see this standard written on the cable, 568B, TIA EIA, which is a standard for that cable. Meaning,
commercial buildings?
Yeah, for commercial buildings, even though most home users have this as well. Yeah, but that makes sense. Usually it trickles down to the homes after businesses have whatever in networking. Either gets cheap enough for home users to get it. IEEE, I've already talked a little bit about that, but the goal of this is different than anyone we've talked about so far. Its goal is to promote development and education in electrical engineering, computer science field. So everything that we do in the wheelhouse in this building, electrical engineering, computer science, all in this building, meaning whether you're a programmer, whether you're a networking person, whether you're going into electronics, whether you're going into engineering, this would be a good group to be a part of. And they do have a student chapter. They host symposiums, conferences, and chapter meetings on a monthly basis. They maintain a standards board, and they have major technical papers and standards that they write. Very highly respected as well. If you join them, you get like a monthly magazine, and again, you can take part of all the benefits of being a member of all the different conferences that go around. ISO is International Organization for Standardization. They're headquartered in Geneva, Switzerland. They are a collection of standards organization. They represent 162 countries. This organization does. The goal is to have standardizations for no global barriers for technology, basically, to where what one country has, another country can have, right? Regardless of finances, regardless of people's living conditions or lack of living conditions, everyone should have access to internet, computers, technology, education, things like that. And that's what this group lobbies for, and raises money, and companies donate money to them to establish, like, say, hot spots and cafes in the middle of nowhere for kids and families to take college courses online, to learn coding, to communicate with folks in the U.S. So it's a good organization. It's widespread authority. ITU, International Telecommunications Union, specializes in the UN, United Nations, which was ratified, I believe, in 1968 or something like that. Regulates international telecommunications, provides developing countries a technical, 1947, provides communications with other countries and expertise and equipment. It was founded in 1865, disbanded, and when Israel became a nation, United Nations was born in 47. Members are 193 countries within the UN, and focus is global communication. Mainly on this one, it's internet services, being a wide broadband, free broadband and wireless broadband. And you'll hear about a term this semester called WiMAX, which is basically internet for entire regions within a 30-mile radius can get internet on drops that have WiMAX installed. And there are some U.S. cities, by the way, that have that. KC has that, Kansas City, Missouri has that, Utah has it. And you basically, if you live in those vicinities, you get high-speed Wi-Fi just by living in those areas at no cost. Google provides a fiber high-speed Wi-Fi network. ISOC, Internet Society, founded in '92. Professional membership establishes technical standards. Current ISOC concerns is rapid internet growth. They're the ones that actually began the work in IP version 6, which we have now in every NIC card, because we'll run out of internet addresses eventually. I think they said by 2025, 2030 we would run out. Information security, stable internet addressing services, and open standards to where anybody and their brother should be able to have access to operating systems, programs that operating systems create. And for the most part, except for Microsoft, and I believe that's it. Apple's opened up theirs. Linux has always been open. But if you know, the hackers tackle which one of the OSs the most, you think?
Windows.
Windows. And the reason for it is because of that very last item right there. They have closed standards in Microsoft. So we'll talk more about that this semester. Things that you can learn, we can learn from that. ISOC overseeing groups with specific missions, like the Internet Architecture Board is a technical advisory group, oversees Internet's design and management. And then the IETF, Internet Engineering Task Force, sets Internet system communication standards, particularly protocol, operation, interaction. Anyone and a brother can submit proposals. You do have to, though, go through an elaborate review process. I used to be a grant approver for people that submitted grants. And here's how that works with grants. If the grant says submit a 35-page paper with, let's say, single-spaced, a certain font, and you submit a page, 36 pages with the same font and size that they told you, it's not accepted. And so simple stuff like that to more exact stuff like you have to put it in the proposal in the order they ask you to put it in there in a certain way. So if you don't do things in the order they tell you to do it, basically it's thrown out. But once it is accepted, it goes through a review process and testing and approval. And items that would go through this one would be, say, new technologies that have to do with internet changing global standards, whether it be internet devices, whether it be, and that would be a good example, internet devices, to where basically you can use the internet to, say, find where people are through GPS. That was one of them that went through a while back, years ago. Because when it first came out, nobody could see anybody but themselves when it came to mapping on mobile devices when they first came out. But now in every OS and every mobile operating system, you're able to see not only yourself, but you can turn it on where others can see you as well if you want to. You can turn it off where others can't see you, but you can also share your location, right, with anyone. I don't recommend it with every app that you have, but there's some that you might want to keep it turned on for, like Maps is a good example. Good idea to keep Maps, knowing where you're at, especially if you're going to use it for directions. IANA and ICANN, Internet Protocol Address is the first one. And IPs basically is what we use in computer networks to talk to each other, okay? And it's more than just internet, it's for intranet as well, meaning being able to share files on a network one to the other, being able to share files on a network file server, being able to authenticate on a network file server. So anywhere you go on campus, or if you work at a location where you log in the morning, you're authenticating through an IP address, using that IP address with your username and password. Has a centralized management authority, usually. And IP address management history, the initial one was IANA, Internet Assigning Numbers Authority. In '97, there was 3 registrars the IAN, the American Registry for Internet Numbers, IPNIC, the Asia Group, and RIPA, the European Group. That was in 97. But since then, in the 90s, they grow to ICANN, you might have heard of. ICANN is the new umbrella of all internet numbers. So every website that exists in the world that's registered through like a domain provider like GoDaddy, ICANN is the grandfather of that registrar. They keep track of all those numbers. And so it's private nonprofit corps responsible for IP addressing. They perform system administration. They do have many administrators that work for ICANN because it's a big job keeping track of all the IP addresses that are coupled with websites. Users and businesses obtain IP addresses from internet service provider. Like if you have Xfinity and you're a business, you can get up to 2 to 3 dedicated IP addresses just for your business. ICANN would be a part of that reporting system that would be reported to those IP addresses. Because nobody else in the world has those IP addresses but you. And so it has to be unique to you. The OSI model. One of the questions in the little quiz we did tonight is basically just a model for understanding how networking works is all it is. It's not perfect, it's not technology, it's not hardware, it's not software, it's just a model that we use. Bless you. It was developed in the 80s to help networking professionals like ourselves to determine where problems lay at in a network, okay, to be able to troubleshoot. So you have the physical data link, network, transport, session, presentation, and application layer of the OSI model. And these you do have to kind of know and what they are. One of the questions in the test for Network Plus is the OSI model. The OSI model is protocol interaction, meaning it's going to interact with the layer above and below, you'll see in a second. The application layer interacts with software like Eagle, Chrome, Firefox. The physical layer of the protocol works with your actual NIC card and the cables connected to your NIC card as it goes across the network, and the connectors as well. It's theoretical, it's hardware and software independent. Every network communication is represented. And there's what's called PDUs, which is protocol data units. It's a discrete amount of data. Application layer function that flows through what's called the 65321 protocol flow. And it's a model and sometimes imperfect. So here's an example on the screen there of what happens in the OSI. So on the right side, we see a computer. On the left side, we see a computer. And we'll pretend you're on Eagle and you're sending a message, or like you did tonight, that you put your name in there for the lab. It went through the application layer, which would be Chrome. Let's say you use Chrome, and let's say you used Eagle. It would be 2 applications actually. The web browser and the server for RBC Eagle, which is not hosted here on campus, by the way. And then presentation layer would take your name that you submitted and say, okay, this is a text. This is a text object. It's just your name. No, I don't think anybody recorded your voice or your picture, right, or your video. So it goes through the presentation layer and realizes it's a text type presentation. Session and transport layer converted from digital or analog into digital. And notice it's going from transport to network. Now it's converting it into the data link layer, getting ready to go into the NIC card, going into the pipe of the network, and it's going through in bits now, in 1s and 0s only, in digital format only. So if you were to intercept it, all you would intercept is a whole bunch of 0s and 1s. That's all you would see. As it comes through on the other side into your NIC card, we'll say it's the web server for RBC Eagle. It goes to the physical NIC card of that web server wherever it's located in the world. Goes to the data link layer, the network layer. Transport layer recognizes it's a text file. Session layer begins to push it to present it to the application layer, which is Eagle, and pushes it out into the database to save it for me to look at it later and to grade it. And so then it keeps doing that over and over again. whether it be me and you talking on a network or my computer talking to on a computer across the world. Irregardless, that flow is the same. And what's cool about it is that it does overlap. They do overlap. It's not like an exact, some of them overlap one another as they're going through it. So the top layer does not include software application, even though it's called application layer, but it works with software, it works with applications, the communication between applications. It intercepts a request from an application like send your name to Eagle database, as an example. It interprets the data sent from the network as a text format in this case. Negotiates the protocols, like an example, are you logged into Eagle? Are you logged into Eagle? It does that all the time. All the time it's saying that and asking that question. And that's called the handshaking format. Constantly handshaking with Eagle, wanting to know if you're logged in, if you're logged in, if you're logged in. If you're not logged in, it can't push it through. Like an example is if you sat there and didn't do anything on Eagle for a while, what's going to happen eventually? It'll time out, and then if you go to submit something like your name, even though it's on the screen and you've not touched anything, when you go to submit it, it's going to take you to a login screen basically to log in because you've timed out. That's all in this layer here. Example of the layer protocol would be the HTTP layer, which would be a good example talking about Eagle because it works on an HTTP layer protocol. And what all that means is when you go to Eagle, the first 4 letters in Eagle is HTTP. And it works through port 80, always through port 80, meaning it's always open and it's always available to push and pull data from port 80, from their web server, once you're logged in. So here's an example. We have some software, which is a web browser, collects and displays data. So APIs basically are just a fancy acronym for working with application points of integration of data. And APIs are everywhere. APIs for Facebook, for Twitter, for Eagle, where basically you can use APIs to gather data, to push data. It requests content, and the content could be a video, the content could be your login to Eagle, and it retrieves that data for that web page. Protocols in the presentation layer accepts the application layer information, formats it, and like the example I gave earlier of your name, it's a text format, but it could be JPEG, GIF, TIFF, MPEG, QuickTime. And the presentation layer manages the data encryption, example, SSL. So if you go to your bank account, hopefully it's an SSL secure socket layer website. Otherwise, I wouldn't go there if I was you. Make sure it's secure. And here's what it would look like. You'll notice it has the HTTP like the last slide did, but it also includes in it the TLS, SSL, etc., which is the encryption for that website to encrypt your data while you're on it. All within the presentation layer. Session layer. This is a protocol function, coordinates and maintains communication between 2 nodes on the network. So it's getting ready to leave the application, right, and transport, and getting ready to go to the NIC card at this point. So it's determining here, it's an ongoing communication of where you're at and where it's going to go. So in this one, it needs to know your IP address and the IP address of where it's going, all right? So let's say your IP address is 192.168.1.5, and you're going to a 203.24.1.4 IP address. It's going to know that in this session layer. Session layer also establishes and keeps everything alive, keeps your connection alive. Have you ever downloaded something from the internet and it started out really fast, and then within seconds it was like dirt slow? Anybody had that happen before? Well, what's happening is your connection's still alive, but the server you're downloading that from more than likely is throttled that download speed because a lot of people's either hitting it that time of day, or they do that for every download all the time. Now, have you ever had a download completely stop and then you go back to your computer and you restart it, and you start right off where you left. What keeps that going is this right here. The session layer keeps that connection going of where the file's at right now and how much it needs left to download. Okay? So it knows that at any moment's notice. Once you log in and authenticate, or you refresh your web browser and say, would you like to start the download again? Yes. It'll pick it up right where you left off. You don't start over again. It also is in charge of terminating communication. So when you log off of Eagle, it is in charge of that as well. So if there's a problem with Eagle on logging in networking terms, we would say it's in the session layer of the OSI. We're having a problem in the session layer of the OSI because it's having a problem logging in. People having a problem logging in, or people having a problem staying on once they're logged in, which has happened before. So it's supposed to time out and say 10 minutes. It timed out in a minute or 30 seconds, and people have to keep logging in. Setting terms of communication, like an example would be the time it takes before it logs out. You can set that on the server. It can take 10 minutes, 20 minutes, or never. You can keep it active all the time. Identity or identify session participants also is in this one. At any moment's notice, in this one you can actually determine who's logged on to your computer, onto your network, onto your service, onto your application. So here's an example of a session layer protocol managing multiple communication devices. We have the web, which is always represented as a cloud, and a couple servers in the middle of the picture there. And on both sides is voice over IP internet phones, like we have in the room and we're on campus. You'll notice a constant thing is happening here. A request, go ahead, are you still there, are you still there, end call, okay. But the middle part, the still there, still there, still there, still here, still there, so that continually goes on until you disconnect. Till you hang up the phone, till you, in this case, till you hang up the phone is when it would be, when it would disconnect. But while you're still talking to a person on the phone, on a voice over IP phone, in this example, you're still gonna, that middle part is gonna be constantly moving all the time, until you end the call, then it ends that transmission on the session layer. The transport layer accepts data from the session layer, handles flow control, end-to-end data delivery. If a data packet falls, you'll see it in the video in a second, it'll ask it to repeat the data packet and send it again. Even if it's across transatlantic ocean to get it. It just takes milliseconds to get it. That's how fast it can travel. Connection-oriented protocols is established by the TCP/IP protocol, which if we didn't have that, we wouldn't have intranet, internet, and wouldn't be able to log in. We wouldn't be able to download files. We wouldn't be able to upload files. We wouldn't be able to browse the web. Now, Tim Berners-Lee, very first person that created the very first web browser, was from the University of Illinois. Him and a roommate of his developed the very first web browser called navigation, was the very first term they gave for it. Anybody know the name of what the website or the web browser finally became? Netscape Navigator. And that was from Illinois, by the way. Most people don't know that. But this is where the handshake is constantly taking place in a web browser session all the time of connections that they're connected to. Now, way back when they first started, all we had was what's called, and I'll date myself here, listservs. Anybody remember listservs? Are basically just a website you could go to from colleges all over the U.S., like Berkeley, MIT, and you would have these little plus and minuses you could click on, and you say in a listserv you want to go to for computers. I click on a computer plus symbol, and it would expand it, and it would go into, say, programming and graphics, design, and whatever. And you click on each one, and it'd be just like text is all it was, where people could type in messages, reply to messages, reply to posts, like a really crude messenger, right? Text only at that time. No pictures, no video, no sound. And listservs was the very first big thing on Netscape Navigator that was used by Tim Berners-Lee's web browser. And then over time, it evolved and got better. And then we had browsers like that came on the scene from Microsoft and Apple and Firefox and Chrome. But by the way, Netscape is still around. You can still download it. People don't use it anymore, but they are credited for the very first web browser, which is pretty cool. And it's from our own state of Illinois. And so the last example here on a three-way handshake, what happens all the time, it's literally like you handshaking with a person. When you initially handshake, it acknowledges that person exists, or in this case, that authentication exists, that username exists, that password exists. Then the next one goes into the acknowledgement, synchronization, which was like that prior slide. It's a continual, are you there? Yes, I'm here. Are you there? Yes, I'm here. Are you there? Yes, I'm here. Back in the dial-up days, anybody remember that? Okay. A couple of you are shaking your heads. Well, when you dialed up to modems, which I had for years, the first thing it would do is make a really high shriek sound. And what it was doing during that shriek sound was handshaking. It was handshaking to make sure I was who I said I was, with my username and password was in the system. Once I was in the system and it authenticated it and synchronized it, the last one came on, the ACK, the acknowledgement. Then the shrieking stopped, and then I was connected, and then I could browse the web very slowly. In fact, I'll share a story. I taught middle school right when dial-up was going out and broadband was coming in. But our computer classes were still set up with dial-up, right? Our instructor station was anyway. Well, with broadband, we had it set up, but it died. It didn't work. And so I had to revert back to the dial-up. I had to share my dial-up connection with the entire class of 30 computers. If you remember anybody remember middle school, 7th grade, 8th grade? I mean, you were buzzing, man. You were like from bell to bell. You were like, just like, it's like just going. And I had them right before lunch, this computer class. Anyway, I had this lesson all built up, as they're supposed to look at these pictures, decide, what type of picture they're looking at, research it on the web. Well, but, I had it planned out with a broadband connection, so it was going to go a lot faster. Nothing like the speed we have today, but still, for what we were used to, it's going to go fast. But anyway, I had them all shared on dial-up, and the kids were all sitting there in front of their computers. I said, okay, go to this website, click it, and it was the first thing that loaded was a picture. Well, we were on dial-up, so the picture would literally creep. It's like they go, and it stopped, and the kids would go, I think it's moving. No, it stopped. No, it's moving. No, it stopped. And 20 minutes of that, right? And so at the end of the class, this one kid came up to me. I thought he was just the worst class. We only went through 2 pictures, I think the whole class. And the kids were so excited when the pictures load up, they'd scream and yell and holler. This one kid came up and said, that was the best class picture talk I've ever been at. Okay, sounds good. Just on 2 pictures, but the reason I mentioned that story was we had in that, I was connected to the internet on my instructor station. It acknowledged it, but because of limited bandwidth on dial-up, I was sharing a 56K modem with 30 computers, basically, is what I was doing, which is kind of funny. Now, continuing on, this was actually in the quiz you guys did, the poll, checksum. A checksum basically is just a unique character of strings put together when a file's created to check to make sure when it's downloaded it actually is the same size, with the same timestamp, and the same user created it. All right, that's what a checksum is. And it matches. If it doesn't match the size, the IP address or the servers, or the router will actually call for the new IPs to be sent that are dropped and be sent to fulfill that download to complete. And this is the part actually of the checksum when talking about the file download earlier. Your computer knows the file's downloaded from a server when it sees that checksum file matches the checksum file on the server where you downloaded the file. Connectionless protocol does not establish connection with another node for transmitting data, does not check for integrity, and it's faster than connection-oriented protocols, and the reason for that is there's no protocols connected to it. It's literally wide open, wild, wild west. You can do anything you want to on a connectionless protocol, but you have no rules to govern what comes in and what goes out. That's only decided. So that's why we need the transport layer to wrap around IP for all the rules. Now, the next one we're going to talk about is segmentation. And this kind of gets into what we're going to watch in the video. When data goes across the network, it breaks into what's called segments. And say you have a 5 meg file, it might break it up into, say, 1,000 little segments. Each segment is a part of the 5 meg file. And I like to think of it like a caboose is on a train, and each one is a certain amount of data that it splits it up at. Then when it gets to the destination, it goes in one nice file. All those cabooses go into one nice big file, and it's all put together. Segmentation increases data efficiency and transmission on certain network types, and the largest caboose is 1,500 bytes per caboose, basically. That's allowed to, even in networking today. And so as it's going across the network, your data is split up into millions of pieces maybe. It goes to the other end, we'll say Eagle server, and it's repackaged, saved into a database. But it could be literally hitting on the path to that server. All these data packets could be going in all different directions. Not just one pipe, many pipes, many routers all along the route. But when they come back to the destination, they're all gathered, connected together, put in the order they were connected, checksummed, checked, and stored. That's pretty crazy. And that technology, by the way, has not changed since networking has started back in the late 80s. Networking technology has not changed.
Using the network,
Yep.
and it has these different protocols.
Right?
Are they different types of protocols, or are they all the same one that
Yeah.
everybody's computer?
Yeah, different. Well, it depends upon how you're sending. Like the sending RVC lab tonight, that'll be going through HTTP protocol. Okay. If you're downloading a file from a network, could be FTP protocol. Yeah, everybody here would be HTTP. If you're downloading a file from a web server, it could be FTP protocol. If you are doing chatting or messaging, it could be TCP and UDP protocol. So a lot of different protocols it could be, but it depends upon what you're doing and what's being done on the network, basically. But once it gets back to that data segment, as far as when a caboose is done, it's repackaged everything and reassembled it. This is the cool part. It sequences the data back in the order that it was packaged in originally before it was taken apart, basically. So whether it's a 5 meg file or a 5 gig file, doesn't matter. It's going to do the same thing on either size of file. It's going to do the same thing. The 5 gig file will just have more cabooses that'll split up and go its merry way, and go whatever route it can go to get there the fastest, and then be repackaged. So we have in this example here, very crude example, but it makes the point. On the left side, a very long message, broken apart into little cabooses. Long message goes to the network, recompiled in the order it was sent, and sent to the computer through the transport layer segmentation. This is just a screenshot of what it looks like actually in the network. If you were to capture one of them, notice it has at the very top of this the source port, which is port 80, destination port 1958, sequencing and acknowledgement, that's the handshaking I talked about earlier. Port 80, anytime you go on the internet, it's going to be port 80 by default. Destination ports there, sequencing, acknowledgement, header. Now these flags are what you see on would see on a modem when you see the dial-up days, but your NIC cards even have lights as well. If you look behind you on whatever NIC's behind you, I know the front row here, or the back row can't see in front behind you, but you should see lights on that NIC card. Generally it's going to be a green or a yellow light, If it's yellow, it's meaning there's collision occurring. If it's green, everything's good to go. And then you'll also notice under here where it says window size, 5840. The reason that was made that way was back in the old DOS days, before Windows mouses existed, the maximum screen size you could have on a DOS screen was 5840. That was it. And that's why it's there as it is today. And that's only in version 4 though. Version 6 doesn't have that. Yeah.
How big would that be?
Depends upon your monitor that you had and the resolution of your monitor. So like my first computer was an IBM 5-inch monochrome screen. It took up the entire screen, corner to corner, took up the entire screen. But say you had a 12-inch monitor, it would still take up pretty much that entire screen because of the resolution of the monitor. You know how you can have different resolutions on your monitor today? You have like 800 by 60, 600 to 12 whatever by 600 and 1200 by 600, and it's going to determine how it morphs that window size. The checksum, notice it says correct, meaning it was checked that file was correctly packaged and segmented and brought back how it was sent. The byte size was 4 bytes in this case. Maximum segment size of the cabooses was 1460 per package. The network layer protocol, it works with the physical layer. We're getting down to the NIC card now. Started with the application layer, we're now into the network layer at the very bottom. The NIC card translates the physical address of the NIC card. The physical address of the NIC card is actually 2 components. The MAC address of the NIC card, which is hard-coded on the NIC card at the manufacturer, and the network address given by the network server in that environment. The network address for that NIC card. So you have IP address, you have network address, you have MAC address. I know you've heard of IP address probably, maybe MAC address, but maybe not network address. Network address is a third one that basically the network gives every computer and every NIC card. The addressing is unique for every device. The types of addressing I already talked about. So here's an example of a network address. Example of a physical address, which would be like a MAC address. Factors would be delivery priority, network congestion, quality of service, other alternative routes, and routers in the network. How heavy they're being hit. Like if you hit on networking here on campus at noon, it's going to be much slower than it is at say 10 o'clock at night on campus or 9 o'clock at night on campus. If you go around campus like downstairs or across the campus and go to the student center, much faster because there's going to be less people on the network. Common network layer protocol is also in the network layer. Fragmentation is in this one as well to have greater network efficiency. This I won't bore you, but basically it's just telling, I will mention the bottom 2, the source IP address and destination IP address of where this is going, because the NIC card needs to know where it's going, where this data is going. The source would be your computer. The destination would be the example I gave earlier of say the RVC Eagle web server. The data link layer is actually the cabling across that you're using, the backbone of the network. Could be Cat5 like we have here, could be fiber, could be wireless, could be satellite, could be oceanic fiber as well. The frames within that data link are put in what's called a payload data packet and sent across the network in those cabooses I talked about earlier, with the error checking in there, the control information in there, which has the source and the destination IP, any other wrappers that might be in there as well. This slide, all I need to talk about is the error checking is done in the data link layer to determine that the data has been sent and received. And it's done through the MAC sublayer and the physical layer, the physical address, which is a fixed number associated with each device's network interface. From switches to routers to your NIC card, all have physical addresses. So we have Your data link is broken up into the physical and network layer, and data flows across it, and data packets and then frames to get to where it needs to go. Now, this is a common NIC card that is wireless. So if you ever wanted to not run Cat5 in your home and have a desktop computer that you want to, say the NIC card goes out on, you want to replace it, you can replace it with one of these, anywhere from 35 to 50 bucks. This D-Link is actually about $40. And you'll notice a MAC address here that is circled. That's done by manufacturer, on the manufacturer before it's packaged. The number is going to be partly manufacturer number, part random number, but it's going to be unique for that device. Physical layer, I've already talked about these some, but you have either copper transmission, fiber, wireless. Copper, by the way, would be like your Cat5 cable, your cable like you have in your home, coaxial cable. And they do have a certain amount of voltage running through them. Not nothing to knock you on the floor, but there is a certain amount of voltage for that data to flow through. And I think I might have mentioned here, correct me if I'm wrong, most students aren't aware of this, that's why I mention it, is you can buy devices to send your, set up your network through the power supplies in your home, for the power ports in your home, the plugins. 2 boxes you can put in, plug in one in your wall with the Cat5, plug in one upstairs with the Cat5, connect it to your router downstairs or something, and you have internet between the 2 floors now through the actual electrical wires in your house. Other is fiber optic, light pulses. Wireless is electromagnetic waves. Okay, let's go through this last OSI slide here before we do the video. So the 7 layers of OSI are these: application, working with software, presentation, encryption, compression of that application type, whatever it might be, text, video, whatever. Session, establishes and maintains connection. Transport, takes that data and begins to package it and to put in the delivery information. Network, adds into it the transport information for the network package. Data link, adds in the frames and breaks it up into cabooses needed to go across the network, up to 5,400 bytes per caboose. Physical layer is where it actually goes from the NIC card to whatever medium you're on, whether it be wired or wireless. And so that's the 7 layers of the OSI. All right, now I'm going to go to the actual video here, which is almost there, right there.
Everyone's wondering when the new technology comes up, like Windows updates.
Yeah.
We had the Internet Protocol version 4 and 6 and all that. Does that come up with when you have Windows updates? The
No.
Technology or when does
It's already built in. It's already built into the network.
It's already built in?
Yeah, nothing new. It's been around since networks have existed and hardware for network has existed. What we're talking about tonight has been around. Nothing new.
Yeah, but when the version, like you said new one 6, right?
Yeah, it's already out. If you have a computer within, I'd say, 2.5, 3 years old,
Yeah.
it has version 6 on there as well as version 4.
Okay, but if you didn't, you have an older machine, it doesn't update.
99.9% of machines in the world today work off of version 4 still, like we do in here. Yep, so you're good. More than likely, that change won't occur till about 2020, version 6 in widespread use, or starting widespread use. It'll start with governmental, then military, and then go to the consumer level then, and businesses.
I just was wondering when those files are updated or if they're updated.
No, it's not actually not files that are updated for
It just
version 4 and
comes in
version
with
6.
the computer and that's it?
Well, it's actually on the hardware. It's on the NIC card
Oh,
itself.
it's on the hardware.
It's on the
itself.
hardware itself, right?
Okay.
Yep. So NIC cards are like these,
Mhm.
have 4 and 6. Wireless NIC cards have 4 and 6. Your phones have 4 and 6. In fact, most phones today actually are working off. A lot of new phones are working off 6, not off 4. So, yeah, good question. Or they're working off both. All right, now if I turn off these lights, you're not going to sleep, right? All right, here we go. I've got it plugged in before I turn the sound on. So if I turn the sound on, then plug it in, you get the big. big, all right, here we go.
For the first time in history, people and machinery are working together, realizing a dream. A uniting force that knows no geographical boundaries without regard to race, creed, or color. A new era where communication truly brings people together. This is the dawn of the net. Want to know how it works? Click here to begin your journey into the net. Now, exactly what happened when you clicked on that link? You started a flow of information. This information travels down into your own personal mailroom, where Mr. IP packages it, labels it, and sends it on its way. Each packet is limited in its size. The mailroom must decide how to divide the information and how to package it. Now, the package needs a label containing important information, such as sender's address, receiver's address, and the type of packet it is. Because this particular packet is going out onto the internet, it also gets an address for the proxy server, which has a special function, as we'll see later. The packet is now launched onto your local area network, or LAN. This network is used to connect all the local computers, routers, printers, etc. for information exchange within the physical walls of the building. The LAN is a pretty uncontrolled place, and unfortunately, accidents can happen. The highway of the LAN is packed with all types of information. These are IP packets, Novell packets, Apple Talk packets. They're going against traffic, as usual. The local router reads the address and, if necessary, lifts the packet onto another network. The router, a symbol of control in a seemingly disorganized world.
Whoops, sorry about that. Oh, let's go with this one here, this one here. Oh, this one goes here, this one goes here. I don't like this one. Let's go with this one, this one goes here. A little bit this left, let's go with this one here. Another channel here. Let's put that one here. Another one there. Let's put that one here.
There he is, systematic, uncaring, methodical, conservative, and sometimes not quite up to speed.
Sorry.
But at least he is exact, for the most part.
That's the one goes there, that one goes there, that one goes there, that one goes there, and this one goes there. Oh, another one goes there, that goes there. He's behind them, let's go there, that goes there, he goes there, oh, let's put that one there,
As the packets leave the router, they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deftly routing them along their way. A digital pinball wizard, if you will.
Here we go, here comes another one, and it's another. Watch this, Mom. Here goes, whoop, around the back. Hey, in there, in there, in there. Over the left, over the right, over the left, over the right. You got it, here it comes, right out, he shoots, he scores. It's going, hey, wait, here, watch out, here comes another one. Oh, here we go, and it's gone. It's gone.
As packets arrive at their destination, they're picked up by the network interface, ready to be sent to the next level. In this case, the proxy. The proxy is used by many companies as sort of a middleman in order to lessen the load on their internet connection, and for security reasons as well. As you can see, the packets are all of various sizes, depending upon their content. The proxy opens the packet and looks for the web address or URL. Depending upon whether the address is acceptable, the packet is sent on to the internet. There are, however, some addresses which do not meet with the approval of the proxy, that is to say, corporate or management guidelines. These are summarily dealt with. We'll have none of that. For those who make it, it's on the road again. Next up, the firewall. The corporate firewall serves two purposes. It prevents some rather nasty things from the internet from coming into the intranet, and it can also prevent sensitive corporate information from being sent out onto the internet. Once through the firewall, a router picks up the packet and places it onto a much narrower road, or bandwidth, as we say. Obviously, the road is not broad enough to take them all. Now you might wonder what happens to all those packets which don't make it along the way. Well, when Mr. IP doesn't receive an acknowledgement that a packet has been received in due time, he simply sends a replacement packet. We are now ready to enter the world of the Internet. A spider web of interconnected networks which span our entire globe. Here, routers and switches establish links between networks. Now, the net is an entirely different environment than you'll find within the protected walls of your LAN. Out here, it's the Wild West. Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping, which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the worldwide wait. But when everything is working smoothly, you can circumvent the globe 5 times over at the drop of a hat. Literally. And all for the cost of a local call or less. Near the end of our destination, we'll find another firewall. Depending upon your perspective as a data packet, the firewall could be a bastion of security or a dreaded adversary. It all depends on which side you're on and what your intentions are. The firewall is designed to let in only those packets that meet its criteria. This firewall is operating on ports 80 and 25. All attempts to enter through other ports are closed for business. Port 25 is used for mail packets, while Port 80 is the entrance for packets from the Internet to the web server. Inside the firewall, packets are screened more thoroughly. Some packets make it easily through customs, while others look just a bit dubious. Now, the firewall officer is not easily fooled, such as when this ping of death packet tries to disguise itself as a normal ping packet.
It's okay, go on, it's okay, no problem. Have a nice day. We out of here. Bye.
For those packets lucky enough to make it this far, the journey is almost over. It's just a line up on the interface to be taken up into the web server. Nowadays, a web server can run on many things, from a mainframe to a webcam to the computer on your desk. Or why not your refrigerator? With a proper setup, you can find out if you have the makings for chicken cacciatore or if you have to go shopping. Remember, this is the dawn of the net. Almost anything's possible. One by one, the packets are received, opened, and unpacked. The information they contain, that is, your request for information, is sent on to the web server application. The packet itself is recycled, ready to be used again, and filled with your requested information. Addressed and sent out on its way back to you. Back past the firewall, routers, and on through to the internet. Back through your corporate firewall. And onto your interface. Ready to supply your web browser with the information you requested. That is, this film. Pleased with their efforts and trusting in a better world, our trusty data packets ride off blissfully into the sunset of another day, knowing fully they have served their masters well. Now, isn't that a happy ending?